This is an introduction to volume. Let's review some of the figures we have learned about. First of all, let's talk about prisms. Prisms are made up of rectangular sides and then their bases have other polygonal shapes. For example, with a rectangular prism, all the sides are rectangles and the two bases will also be rectangles. Now in this particular picture we have a certain type of rectangular prism that's referred to as a cube in which all the sides are congruent, so you can't really tell which sides are the bases. But for the sake of argument, let's say that the red side is a base, then the side opposite will be a base. So prisms always have two bases that are congruent and parallel to each other. Next we have a triangular prism. In our triangular prism, can you tell what the two bases are? Keep in mind they are the sides that are not rectangles. Right, so our bases are going to be triangles in this particular example for a triangular prism. You can also tell what the bases are by the name of your prism. So these two bases are parallel to each other and they have the same area. With a pentagonal prism, what do you think the shape of the bases will be? A pentagon, right? Very good. So we have two bases that are pentagons. They're parallel to each other and they have the same area. And what's the shape of all the rest of the sides? The rest of the sides will always be rectangles in a prism. So the bases of a prism, there'll be two bases. They're parallel to each other and they're the same polygonal shape. All the rest of the sides of a prism will be what? Rectangles, right? Now the rectangles may or may not be congruent. It depends on if your base has all sides that are congruent. What's it called when you have a polygon with all sides congruent? If you thought regular polygon, you are correct. So if your polygonal bases are regular, then all the rectangles will be congruent. Otherwise, the rectangles will not be congruent. So we saw earlier in our previous video that volume is the amount it takes to fill up an object. You can think about it as a lot of different examples. So what do you think would be a couple of things you could fill up an object with? We saw an example where they put ice cubes in a prism. So it could be something like ice cubes. And ice cubes will change into what if you let it stay out in the heat? Water, right? So water could fill up a prism. What else? Maybe sand, all kinds of things, sugar, all kinds of things. So volume is the amount it takes to fill up a three-dimensional object. So we see our three examples of prisms here, and we're going to talk about how to calculate the volume. To find the volume of a prism, you're going to multiply the area of one of the bases by the height of the entire prism. So let's look at an example of this. Here we have a prism. Do you remember what this prism would be called? We have two pictures that are the same prism. What would it be called? It's a triangular prism because the two bases are triangles. So I've shown you here what the bases are. So the two bases are the triangles, and I've shown you what the height is. The height is the perpendicular, that's the perpendicular symbol, distance between the two bases. So the length that connects the two bases is called the height. Now we actually can have more than one height just like we have more than one base. Do you see some other line segments that are heights that connect the two bases? Here's one. That's a line segment that connects the two bases, and here's another one. All of the heights will be parallel to each other and they will be the same length. So when you're calculating the volume, what you're going to do is find the area of one of your bases. It's called the base area. And then you're going to find the height and you're going to multiply those together. So let's talk in a little bit more detail about what that means. So capital B means area of base. And it's capital to mean area of base instead of just base. So that means you calculate the area of your base. And you just pick one of the bases. They're both the same area. So in this case, we need to know the area of our triangle. Let's say that it's 25. And do you remember with area if I would have centimeters, centimeters squared, or centimeters cubed? If you think squared, you're correct. Our units are always squared with area. And then for height, I already told you that that's the perpendicular distance between the two bases. So for the height, in this example, let's say that it is 10. Now, this is the length of a line. So for the length of a line, would that be centimeters, centimeters squared, or centimeters cubed? If you thought centimeters, you are correct. So we're just going to multiply those together. So the volume would equal 25 centimeters squared times 10 centimeters. So what would our volume be? If you said 250, you're correct. Now what about our units? What do you think centimeters squared times centimeters equals? Centimeters cubed. And you can think about it with algebra. This is like having x squared times x, which equals x to the third power when you talk about the centimeters. So centimeters squared is like your x squared, and centimeters is like your x. So x squared times x is x cubed. Centimeters squared times centimeters is centimeters cubed. You can also think about it with geometry. We have 3 dimensions. We have the height, and with the base, we have 2 dimensions that actually give us the area of the base, and we'll talk about that in more detail later. So we end up with 250 centimeters cubed. So let's look at some other examples. So here we have a pentagonal prism. So let's say the area of one of the pentagons is 40 inches, and would that be inches squared, or inches cubed for area? Inches squared, right? And then let's say the height, the distance between the two bases, is 5. And would you say inches squared, or inches cubed for a length? Should be just inches, right? So what would be the volume then? We want to multiply the area of the base times the height. 4 times 5 is 20, and then you need to put this other 0 down. And what's inches squared times inches? Inches cubed, right? That ends our introduction to volume.